Hello, everybody. The lab we're doing today involves measurement and learning how to measure using specific tools in the lab. Now, the main tools we're going to be using are balances, graduated cylinders, and rulers. Now, with every tool, anytime you go to measure with that tool, you have to look, what is the smallest marking? And then you estimate between the smallest marking. Now, here we have two balances. We have a triple beam balance right here. So we have the picture of the whole thing. And then this is a zoom in part, which allows us to see the scale right here or the markings. Now, you will see how a triple beam works later on in the video. I will demonstrate how to use it, but it's used the same way that you would use in the doctor's office. And it's really only just works on gravity, right? So what you're doing is you're balancing out an object on a pan with counterweights on the other side, and when it's leveled out, you know exactly what that mass is. Kids hate using the triple beams or the quadruple beams because they're slower, but they're actually really pretty precise and really have pretty good accuracy as well. They're pretty good devices. Now, we're going to be using this balance as well as an electric balance or an electronic balance today, just to demonstrate estimating and then using the electronic balance, which automatically gives it to you, gives you the value. So you're going to put an object on the balance, and then you're going to adjust the small lever. And let's say that the small lever, when it's balanced, ends up right here. Let's put this in red so we can see it. Okay. Now, our smallest marking here is at the 0.01 gram position, which means I can estimate to the 0.001 position. So all masses with the triple beam or the quadruple beam, which is what we have in class, should be estimated 3 places past the decimal. So you would read whatever the hundreds is, whatever the tens is, whatever the ones is, and then it would end with 0.5. And I would count over 1, 2, 3, 4, 5, 6, 7. I counted 7 over. And then I'm going to estimate in between the 7 and the 8th position. And I would say it's probably, if I'm looking at the middle of the arrow, I'm going to say 6 grams. Now, because this marking is so small, because it's so small in here, and it's really hard to see, you probably can't break that into tenths, but you definitely can break it into halves. You could definitely break it maybe into every every fifth. So you still should be estimating, but you maybe aren't really be able to estimate to have your eye break it up into tenths. Now, when you have an electronic balance, like we have here, and ours are a real small kind of stripped down version of this, when you put the object on the balance, this one goes 2 past the decimal. There is no estimation going on. So let's say it reads 5.76 grams. This 6 right here is the balance's best estimate of what that position is. So that is already doing the estimation for you. You do not need to estimate when using the electronic balance. You just read what it is, but you recognize that the last position that's recorded gives you the estimated position. All right, now let's talk about how you properly mass an object. Now you might think, oh, that's ridiculous. Of course I know how to mass an object. I just put it on the balance. Well, number one, you never, ever, ever put anything directly on the balance. You should always use a weighing dish. Some people call them a weighing boat. There's also weighing paper. You should always have something in between the object and the balance, even if it's something as simple as a penny or a marble. I mean, yes, those are not going to hurt the balance. It's just good practice to always have it in some sort of container. Now, there are 2 ways that we can account for the mass of that container. Your teacher will tell you which way they prefer, or if they prefer a particular way. I prefer the second way. I prefer the subtracting the mass of the dish, and I will explain why in a minute. All right, the first is we can look at, oh, I didn't mean to move that. We can look at something called the tare button or the 0 button. Now, what we have is we're going to have a balance. So here's my balance. Anytime you start up a balance and there's nothing on the balance, you always look to make sure it reads 0, and you always check to make sure it's in the proper unit. So you should always check to make sure it reads 0 and that it's in the unit of grams. Because if it's in a unit of ounces or something else, you're going to have to either do a conversion or redo the whole lab. You are then going to take your dish, you put the dish on the balance, and now the balance goes up to, let's say it goes up to 2.43 grams. Balances have a button on them that says tare, or sometimes just a T button, or it says 0. When you hit that button, the balance goes back to reading 0 with the dish on it. So now when you go to put your object in there, the balance will increase to say 10.53 grams. That is the mass of the object and the object alone. Now, the danger with doing the tare button, with using the tare button, is as soon as you take this dish off, as soon as you remove the dish, the balance is going to read a negative number. So now the next time you go to put something on the balance, you better make sure that that balance reads 0 again. You always need to be keeping track of, is the balance zeroed out? Okay, that's one way. The other way is the way that I prefer, and I'm going to have my classes do this. The other is you have to do a tiny bit of math. So you have your balance, and the balance, you should always, again, make sure that it reads 0 and then it reads the proper mass, proper unit, I'm sorry. Then you take your dish, you put the dish on the balance, and now the balance goes up to whatever the mass of the dish is, and let's say the mass of the dish is 2.42. So what you're going to do, you are not going to hit the 0 button. You're going to record the mass of the dish in a data table. Now, what we're going to do is, let's say that the real or the accepted value for the mass of the dish is 2.42. But let's say your balance reads off a little bit. Let's say it's 0.3 grams off. It's not calibrated. Calibrated means I put a 25 gram mass on the balance. It reads exactly 25 grams. I've compared it to a standard, and I know that the balance is reading accurately. So let's say that it really reads 2.72 grams. So this is the balance, and this is the real value. Okay, so the balance is reading a little high. So you might initially say, well, that's a problem. Our values are going to be off. Well, let's wait and see what happens. So now let's put my object in here. And now my balance goes up to 10.93. So the balance is reading 10.93. But it should, the real value, it should be 10.63. Okay, so the value that I put here is the balance reading inaccurately, whereas it should read the 10.63. So this is dish and object. Now, to get the mass of the object, I subtract out the mass of the dish, and let's see what happens. 8.21 grams, 8.21 grams. So when I subtract out the mass of the dish, it also subtracts any error that may happen due to an uncalibrated balance. So anytime you're getting a measurement, and this could be with volume as well, where you are getting the value by difference, you're subtracting something out, calibration doesn't matter. And this is why I prefer this method over the first method. All right, so these are graduated cylinders, and graduated cylinders are used to measure volumes of liquids. And we can get graduated cylinders in all sorts of sizes. So here we have graduated cylinder, we have 5, we have 10, 25, 50, and 100. And this again zooms out to this image where we have an expansion of our markings. Now, again, we're always going to look, what is the smallest marking? So the smallest place is the ones position. So I better estimate to the 0.1 position. All of my volumes with a graduated cylinder like this, 100 mil, you better be reading to one place past the decimal. Now, when you start using what are called long form 10 milliliter graduated cylinders, they're much narrower, they have more markings. You can actually read two places past the decimal with those. So you, again, have to be very clear, what position am I reading to? Now, with a liquid, particularly a water solution, it's going to curve, and this is called a meniscus. Now, the smaller the diameter of the tool, the more pronounced the meniscus is going to be. Whenever you read a graduated cylinder, you're going to read the bottom of the curve or the meniscus. So for this particular volume that I drew, you're going to read the bottom of that. So if I were to read the volume that I just drew, it would be 87, and I have to estimate in between where the 87 and the 88 is, and I would say probably about 87.5 milliliters. Now, whenever you're choosing a tool, you need to choose the appropriate size for the sample. So you're always going to choose the appropriate graduated cylinder size for the sample size, because you want to maximize the scale. And this will make sense when we work on in a couple slides. Okay, so if you're trying to measure out 12 milliliters, you certainly are not going to do that in your 100 mil. If you're going to measure out 12 milliliters, you're probably going to use a 25 mil graduated cylinder. If you want to measure out 90 mils, clearly you're going to use 100 mil. So there's going to be a little bit of choice in what tool you use for the particular sample size. All right, and the last thing we're going to be using is a ruler. And again, you look, where is the smallest marking? Smallest marking here is the 0.1. So every time you read a ruler, you need to estimate to the 0.01 position. So if I have something that goes out to here, what I'm going to do is I need to make sure that I indicate two places past the decimal. And let's assume that it is exactly on the 8 here. The answer is not going to be 8 centimeters because that only has one significant figure. You need to estimate 2 beyond. So you would write 8.00 centimeters because that is indicating the precision of the tool that we are using. All right, this picture right here is a snip from your lab itself. And I want to talk about this chart right here and how you're going to fill out this chart. Okay, so for every tool that you're using in this lab, you need to indicate what is the estimated position or the precision for this tool. For a 100 mil graduated cylinder, that's the 0.1 milliliter position. Now, what that means is because I'm estimating the 0.1, that position can vary. It's usually, I think with the 100 mil, I think the precision reported by the company is either plus or minus 0.2 mils or plus or minus 0.5 mils. We're going to assume for the purposes of this lab, for the purposes of what we're trying to teach you, that it's going to be plus or minus 1 in that position. So if I record a volume of 9.2 milliliters here, I'm going to assume for the purposes of this lab that the true volume is somewhere between 9.1 and 9.3 milliliters. So it's 9.2 plus or minus 0.1. Okay. Now this particular measurement has two significant figures, and two significant figures is really not a fantastic measurement. If we could get 3 significant figures, that is a much better measurement, and you're going to see why in a second. Now, the percent error due to uncertainty in the estimated position. We're going to use this formula down here. So my estimated position is 0.1. My measurement is 9.2. And then I'm going to multiply by 100. And I get 1.1%. So my measurement can be off by 1%. I'm going to put 1.1% here. Now, if I can increase the sample size, I'm going to decrease that error. If I can increase the number of significant figures by choosing a better tool, I can decrease that error. And this error is error that we cannot control. It's error that is inherent to estimation of the tool. So if we can minimize this by choosing a larger sample size or choosing a better tool, that makes our data much better in the end regarding precision. All right, now we're going to look at the equipment we're going to be using for today's lab. So we have 2 graduated cylinders that we're going to be comparing for measuring volume. I have 2 different tools for measuring mass. I have a ruler for measuring length. I have a pipette. This is a test tube. In your directions it says pen cap. Instead we're going to be using this little test tube. I have some pennies, I have a marble, I have a paper clip. This plastic dish is the weighing dish that we're going to be using. And then I have a beaker for some water. Now the first part of the lab we're going to be dealing with volume. So we're going to be dealing with the 2 graduated cylinders. Now you're going to get the volume of the test tube. So you're going to fill this up completely with water. So you can either use the sink or you can take the beaker, fill it with water, and just pour it right into the test tube over the sink. You're then going to take that volume, pour it into the graduated cylinder, measure to the correct number of significant figures, refill this, pour it into the 10 mil, record using the proper number of significant figures. You're then going to get the volume of the pipette. So in order to fill this, obviously squeeze, pull the liquid up, but we have a lot of air still in there. So hold it upright, squeeze it. You might want to put a piece of paper towel or do this over the sink. Squeeze to get some air out. Fill it back up. Squeeze, and again, do it over the sink or some paper towel. Squeeze. Okay, I still have a little more air. You're going to do it over the sink or some paper towel, not like what I'm doing, and fill it back up. And so now I have all the air gone. Then you're going to put it into the 10 mil, get the volume, put it into the 100 mil, get the volume, put it into the 10 mil, get the volume. Okay. Second, you are going to get mass values using the electric balance and using this is a quadruple beam. So let me show you how to use the quadruple beam. So let me move this stuff aside. The electric balance, I'll do that first because that's easy enough. So you just turn it on. Make sure that the unit is in grams. Okay, it's moving around because I have it held up. Make sure it's in grams, because if you push one of these buttons, it's going to read a different unit, and that's going to be bad. Also, make sure that when you put it down, it reads 0, and if it doesn't, you hit the T or the 0 button. Now that it reads 0, you are ready to go. You put the dish on, you put the object in the dish, you are all set. Now, for this right here, let's talk about how you use this. Now, kids want to always adjust so that this reads exactly on the 0. You don't have to do that, because if it doesn't read exactly on the 0 here, once you get the mass of the dish and it's aligned to 0, then you get the mass of the dish and the object, it's aligned to 0, it subtracts out that calibration error. So do not adjust, do not touch my balances, okay? All right, so what we're gonna do is I'm gonna put the balance on here just so that I have something heavier to mass. Okay, you always start with everything over at the 0 point. You move the heaviest mass first. All right, so you move it until it goes down, then you move it back 1. Okay, so now I know it's between 100 and 200 grams. And when you move it, make sure it's in a notch. There's a little notch, and make sure it's kind of nestled in that notch. Then I move the tens over until it goes down, and then I move it back 1. Then I move the ones over until it goes down. So it goes down, it's going to be pretty close. It goes down at the 7, so I'm going to move it back to the 6. This is the tricky part. You now are going to move this one until the line here equals the line here. And I find it is easier if you use like a little pencil tip. I'm going to use the edge of the ruler because I don't have a pencil handy. So you slide this until it starts to come down. It's starting, we're almost there. It's going to be a little bit more, so adjust it a little bit more. Okay, a little bit more. That's about right. Maybe a little bit high. So this is why kids hate it, because it just takes a lot of little fidgeting. Once you have the line on the arm equal to the line on the base, you now read it starting with the largest unit. So it's going to be 186.8, and then I need 2 places past that 0.8. So right now it's actually at 0.890. Record 3 places past the decimal. The last part is you're measuring with the ruler. Now in your packet, there already is a ruler there for you to measure the length of paperclip and length of a Post-it note, which I actually didn't include in the original equipment. So within the packet, you're going to measure those lengths to the appropriate number of significant figures. Then you're going to use the ruler and you're going to measure dimensions of a triangle that's in the packet. Once you have those measurements, you are all set. You clean up and you are then ready to answer the questions, which will be due the next lab day. I thought I was done, but I forgot to talk about one thing. So we're adding a little video onto the end here. So one part also, not only are you getting volume, mass, and length, you also are calculating a density. And so you're going to calculate the density and you're going to do it of 5 pennies. So what you're going to do is you are going to get the mass of those 5 pennies using the best tool. So you need to choose, am I using the triple quadruple beam or am I using the electronic balance? And then we need to get the volume of these pennies. You need to use the appropriate tool. Now, sometimes you are limited by size. Okay, you might not be able to choose the more precise tool, but you have to choose the practical tool. Here's my hint. So what you are going to do is you are going to put some water into the graduated cylinder, reading it to the correct number of significant figures. Do not choose an initial volume. Do not say I'm going to put exactly 50 mils in and then spend 20 minutes trying to get that exact 50 mils. You put the volume in until it reads something. You read what that volume is, okay? It doesn't matter what the initial volume is. You then take your pennies. Be careful not to drop them from a height for 2 reasons. 1, it can hit the bottom of the graduated cylinder and break it. 2, it can splash the water and cause problems with your measurements. So you're going to take the graduated cylinder, tilt it, and slide the pennies in. Then you are going to read the new volume to the correct number of significant figures. You can get the volume of that by difference. Now you are going to have to do 3 trials with the volume, not with the mass, because the mass is there's not as much error with reading the tools. So we are going to do this 3 times and you're going to report an average volume of the pennies. And then you're going to calculate the density, reporting your answer to the correct number of significant figures. So pay attention to splashing. And do not, if I see you spending a lot of time trying to get a set initial volume, I'm going to yell at you. If you're a teacher, if you don't have me and you have another teacher, they're going to yell at you too, because it is not necessary. And it actually creates a lot more error rather than just adding a volume and reading that initial volume. Okay, when you're done, now you clean up. Last thing you do is you take off your protective equipment. What you need to wear, you do not have to wear the full goggles. You can just wear the glasses because we're just dealing with water and some glassware. So clean up, straighten up, and put everything back exactly the way you saw it. Complete your questions, and then you are all set.